Thank you for tuning in this episode of Data Center Therapy. Down here with Neil Casol, one of our senior consultants at IVOXY Consulting. And of course, I'm your host, Mac Nethkin. I'm the consulting manager here at IVOXY. And today we'd like to talk about VSAN and ransomware. We recently had an issue with a customer of ours that got hit with ransomware. And this is to tell the story of how it affected their VSAN and what they did to recover from it. And with that, I'll turn it over to Neil, who was hands-on, boots on the ground, working with this.
Thanks, Mac. So when I first got involved in this whole activity, the customer had shared their screen up with one of our consultants, and the hosts were sitting. This was a remote KVM operation, and we were looking at the screen of the hosts in this VSAN cluster, and it looked like they couldn't even boot. So normally, you know, in a situation where you're going to remediate some kind of ransomware that's corrupted, you know, virtual machines, you're potentially, you know, going to your backup appliance and pulling back those immutable backups, or maybe calling up your storage vendor and asking them to allow you to get those immutable snapshots brought back into your environment. But in this case, the hosts weren't even available to mount up anything to ingest data. The hosts themselves were crypto lockered. So moving forward, I realized, okay, in a VSAN, so in a hyperconverged cluster, you have your storage and your compute are part of the same managed unit, which is the vCenter. And with the vCenter down and gone, ostensibly, you're pretty much having to start from ground zero. Now, luckily, these hyperconverged appliances that the customer had picked, they're VxRails, no secret here. VxRail basically uses vSAN technology at its core. It's just a brand name for that, you know, combination of appliance and software from Dell EMC. And luckily, they come with a little SD card in each host that allows you to do something called a razor reset, RASR reset. A razor reset is effectively a re-imaging of the host down to the, you know, the operating system level. So it will wipe all data on a given node and prepare it as if it had just shipped from the factory. So the first step, knowing that, you know, the customer's compute faculty was down, their storage was down, was to run this razor reset. And you can go into the KVM and into the BIOS and select that special one-off SD card that's there for exactly that purpose, to reimage the host. So we went ahead and reimaged the hosts. We brought up the stock vCenter image that's contained on one of the nodes and used that VxRail manager and vCenter to then re-image that cluster. And then this is not a real short operation. You're basically having to reset all your networking, having to reset, you know, NTP and DNS and Active Directory and all these things. And it required a little bit of cooperation with the customer, who had an old cluster that was sitting in a corner, powered off with its own attached storage. They had to power that on, kind of bring up base level services for NTP, for DNS and whatnot. And we were able to link those two and stand up, you know, this cluster again. So once that was done, once the cluster was rebuilt, we finally had a manageable units available in a data store that then we could ingress that data from the customer's backup appliance. Thankfully, they didn't have backups within their storage or anything, you know, kind of non-standard like that. They had a separate backup appliance with immutable backups, independently managed, and we were able to bring that data in and rehydrate those nodes with the restored data. But by golly, it took, you know, a good day plus of effort to get that system stood back up and capable of running the customer's workloads.
That's good. So the customer was down for a day. Did they lose any data with the recovery?
So thankfully they didn't. Their backup appliance, you know, I'm a little hesitant to share the name of it. It's not one of the primary solutions that IVOXY run with. We're very well known for running with Rubrik. We do have customers on non-appliance related backup systems, things like Commvault, things like Veeam and whatnot. This other appliance, thankfully, was not corrupted and not command and controlled by the ransomware. Though everything else in the environment was. So the compute was obviously compromised. The storage contained within the compute was compromised. But thankfully, that because they had that external backup appliance element in their environment, they were able to do a restore after a good amount of time. The lesson, though, one of the lessons, is that how long did it take to rebuild that cluster because the storage wasn't decoupled from the compute? And that became a very lengthy process, many tens of hours to get them back online. So
yeah, so what other lessons learned did you walk
sure.
away with from this?
Well, I mean, going approaching the customer early in that remediation engagement, it became very quickly apparent that when an attack happens, if ransomware is in the environment or even just a virtual machine corrupts, your first instinct is to, hey, let's go to the backup system and let's go get these immutable backups or the last known good backup. And where it got complicated very quickly and very apparently, the scenario kind of presented itself is that, okay, well, where's the vCenter cluster and the command and control of the compute? Where's the hosts? And because of this pernicious ransomware, this particular attack, compromised the hosts. And I think innocently, when I did a little bit of kind of security inspection of those hosts before I determined, hey, we need to reset your entire cluster. We need to reload and do that SD card razor reset procedure and bring your hosts back online by wiping them. I had looked at the boot devices on those. So there's a little EFI boot partition that's FAT32 formatted. And those basically allow the ESXi kernel to load, the hypervisor. And even those were crypto lockered. So all the files ended with .conti, with some variant of the Conti ransomware. So the lesson there is that ransomware, even when it's trying to be kind of do its job of crypto locking the data, in this case it was indiscriminate about what it crypto locked. It probably didn't know it was on a hyperconverged host, and it went and crypto locked even the boot files that are needed to bring that up. So when those hosts were compromised and they were rebooted, they rebooted into nothing. They were unable to boot. They were just sat there in a boot loop. And that's where it kind of dawned on me, whoa, hyperconverged is an interesting technology. There's certainly, some pluses about having your computer also be your storage and a self-contained unit. But wow, in terms of the shock of realizing that all the nodes have been crypto lockered, that the boot sectors were gone, effectively any way of booting those in and getting your vCenter back, your storage objects, the keys that basically control encryption on that cluster of nodes that constitute the compute and the storage, they were gone. When it was cryptoed, there's no getting that back. Even if the attackers had been paid off or something like that, are they going to help you rebuild that cluster? Is it even possible? The ransomware was clearly, hey, I'm just going to kind of crypto everything, and it becomes nearly impossible, if not impossible, to truly restore that.
Oh wow! So if it wasn't hyper converged, would the restore have been much quicker?
That is exactly one of the things that kind of dawned on me is, wow, if these were just say 2 to 4 normal ESXi hosts attached to a traditional storage array, could be fiber channel, could be iSCSI, could be an NFS data store. If you had a decoupling of that compute and that storage, most storage arrays are going to have snapshots, every few hours, at least dailies typically is how I set up, best practices when I deploy, my customer storage arrays. you're going to have a known good point in time that you can get back to. And for critical applications, maybe you snapshot every hour, maybe you do log shipping and snapshots. Long story short, you have a good amount of storage-based snapshotting and potentially backups, running from there, that give you restore points that if your compute was compromised, you could quickly reload your compute, then reattach those data stores, revert back to an earlier snapshot. There's just so many ways in which not having that storage tied in to the compute as it is in hyper-converged solutions, that you would have a much quicker, the time to the restore time objective could have been just a few hours, to reload a host in a few minutes with an ESXi ISO, and then, hey, let's reattach it to that storage. And it looks like somebody clicked on the wrong link at this point in time. That's okay. Let's go ahead and revert this data store back an hour, or revert it back 4 hours or 6 or whatever. And let's go mount that up, and let's go power on our VMs and sail along with far quicker, time to resolution and time to get to known good back.
Well, cool. Thank you for sharing that, Neil. This was pretty good information. Anything else to add?
No, I'll just say that, if you, as our loyal listeners, viewers, and whatnot out there in the IT world need help kind of figuring out how to keep your data available, hyperconverged or not, this is what we do. We make sure we have secondary copies of your data. We make sure it's replicated to the other sites or the cloud, and we'll help prescribe the right solution for you if you're looking at a refresh of your compute, storage, network infrastructure. Mac and our network team and our compute and systems teams are really good at making sure we put the round peg in the round hole, the square peg in the square hole. So let us know how we can help.
Great. All right. Thank you for tuning in. If you have any questions or comments, please leave them in the comment section below.